In order to use a least squares regression line, we need to know that our data is linear or fairly lined up. One way of doing that is to plot our data points and take a look at the graph. Another way is to calculate something called the correlation coefficient. We represent that with this lowercase letter r here. Now, this is only for relationships that we think are linear. And what it does is it's a measure of the strength of the linear relationship between those two variables, as well as the direction. So the direction could be either uphill or downhill. And we're going to use technology to help us calculate that correlation coefficient, so you don't have to worry too much about that calculation. The values it'll take on are between -1 and +1. So if we have negative values, like these pictures over on the left, if r is negative, then our slope is also going to be negative or downhill. And then you notice that in the middle is 0, and as we go to the left, we get closer and closer to r equals -1. So these are all our values along the bottom here. So the closer we get to -1, the stronger our linear relationship is. So we see that this is a lot more lined up. As we get closer to 0, it gets more spread out. When our relationship is close to 0, there is no, or at least a weak linear relationship. Okay, now that doesn't mean that there's no relationship of any kind. It just means that there's not a linear one. So it could be something like this, where our points are all scattered. It also could be something curved, like a parabola. And so that would end up with a correlation coefficient of 0, even though there is a pattern here. And that's because, again, that correlation coefficient is only for linear relationships. So when it's close to 0, it means we definitely don't have anything that's linear. And then if r is positive, so that's this right set of graphs, the slope of our equation of our y equals mx plus b is also going to be positive or uphill. Okay, and then as we get closer to +1, so as we go from 0, where we have no linear relationship, and we head through the positives, the closer we get to +1, the stronger that relationship is going to be. All right, so let's take a look at our ice cream sales scatter plot. We're going to apply what we've just learned to this picture. So looking at this, would you say that this looks like a strong or a weak linear relationship? Okay, well, I would say this looks pretty strong. Most of these points are grouped pretty closely around this line. And then as I look at this, do we expect the correlation coefficient to be positive or negative? So look at this, it's going uphill, which is a positive slope. So I would expect that also my correlation coefficient R is going to be positive. All right, before we answer these other two questions, I'm going to have you watch a video, not done by me, but done by someone else, and I thought it was really well done, that shows you how to use Desmos to get the equation and this correlation coefficient. So Desmos will do all of that work for you. So go take a look at that video, and then we'll come back and finish the rest of this.